this video, I'm going to teach you how to determine empirical formula. This is from book 3, topic number 1, the mole concept. So here are the procedures of calculating the empirical formula. So you need to know the following. 1, you write the elements that are combining or reacting. Secondly, you write the combining masses. Thirdly, you write their relative atomic mass. Fourthly, you determine the number of moles. In this we use the formula moles equals to mass over relative atomic mass, as you have stated above there. After getting the number of moles, the fifth step is to determine the mole ratio. How do we get the mole ratio? We do this by dividing with the smallest mole. From the above calculation, you just get the smallest mole, smallest number of moles, then you divide both moles, or if 3, all of them, by the smallest. That will give you the mole ratio. After getting the mole ratio, we write the empirical formula. Get the empirical formula, or EF, sometimes called the simplest ratio. So I'm going to look at an example here so that we are able to determine the empirical formula using the 6 steps that I've indicated for you. So from KLB book 3, page number 83, you're going to look at question number 29, and in question number 29 it states, in a compound of magnesium and nitrogen, 54 grams of magnesium combined with 21 grams of nitrogen. Determine the empirical formula of the compound. In brackets, you've been given the relative atomic mass of magnesium, which is 24, and the relative atomic mass of nitrogen, which is 14. So let's apply the steps. So step 1, we write the elements that are combining, and in this case our elements will be magnesium and nitrogen. Remember, we always start with metal and then we write the non-metal. Our second step, we are supposed to write the combining masses. So here I just write the masses. We have been told in the question that magnesium is 54 grams, whereas nitrogen is 21 grams. Sometimes masses can be in percentage, so you just use it directly. Next step, write the relative atomic mass. In the question, we've been told that the relative atomic mass of magnesium is 24, and that one of nitrogen is 14. So the next thing you do is now get the number of moles. To get the number of moles, we divide the mass with the relative atomic mass. So for magnesium it will be 54 divided by 24, and for nitrogen it will be 21 divided by 14. So at this step, you just press your calculators. So 54 when divided by 24, we get 2.8. 5. Those are the moles of magnesium. When you press the calculator, 21 divided by 14, you'll get 1.5. Those are our ratios. So to get the mole ratio, sorry, those are our moles. To get the mole ratio, we divide these moles with the smallest. So between these two, 2.25 and 1.5, the smallest is 1.5. So it means we divide both by 1.5, 1.5. So our mole ratio will be, let's start with this one. It is 1. Press your calculator, 2.25 by 1.5, you will get 1.5. When you get 1.5 as your decimal in one of the mole ratios, then it means that you divide both mole ratios by 2. So that means this one will multiply by 2. At the same time, this one also will multiply by 2. So, however, if the decimal was let's say 1.1, 1.2, 1.3, 1.4, then that means you do not round off. If it is greater than 5, that is 1.6, 1.7, 1.8, 1.9, then you round off to the next number. So if it is 0.5, 2.5, 3.5, or whatever, you multiply both your ratios by 2. So here we are going to get 3, and here we are going to get 2. Then lastly, we get our empirical formula. So our EF will be Mg. Then you write 3 as your subscript. Then for nitrogen, you write 2 as your subscript. That will be your answer. Thank you for watching.